All right, let's take a look at the problem set for lesson 6 in module 2. And this one has a lesson summary right above the problem set like the previous lesson did. I like when they do that. So let's read it real quick. It says, to find the distance between two rational numbers on the number line, you can count the number of units between the numbers. That would be sort of like your basic, maybe slower way of doing it. But luckily we have a formula that allows us to do it pretty quickly, especially if we're talking about huge numbers that are way far apart from each other. You wouldn't want to count the spaces between negative 7,812 and positive, 4,000,000.2 or something, right? That would take a long time. So we need a formula. We need a way of doing it quickly for any two numbers. And it says the formula for the distance between any two rational numbers, and we're calling the numbers p and q. Those are just variables to stand for the two numbers that we're looking for the distance between. You just take the absolute value of the difference between p and q, so the absolute value of p minus q. They remind you here that distance is always positive. You can't have negative miles or negative feet. You can't have negative spaces on the number line. So the last thing you should always do when you do this formula is take the absolute value of whatever p minus q is, and the absolute value is always positive. But change, on the other hand, may be positive or negative. So for instance, there's a -4 change when the temperature goes from 7 to 3. So if you're strictly talking about change and it's asking you what was the change, then you could say, oh, it changed -4. But if it asks you how much did it change, then usually change is measured just as an amount. And you would say, oh, it changed by 4, even though it was -4. So you have to be sort of careful with the way sometimes questions are asked and sort of like the conventions of speech. But we'll talk more about that in class. So these are all absolute value expressions that could be used to find the distance between 2 points on the number line. So if you think of this as like -19 here is p, and then we're subtracting 12, so 12 would be like q if you're thinking about this formula here, absolute value of p minus q. So this would be exactly how, if I were to ask you what is the distance between -19 and 12 on the number line, this is what you would set up. In the previous lesson, we were really focusing on changing anything where we say minus, -19 minus 12, to, adding the inverse of the next number. So I'm going to just change that minus 12 to plus -12. But I still have my absolute value bars, and I like to make them much taller than everything else, so it's really clear. And so now I'm going to do the math inside the absolute value bars before I take the absolute value bars away by taking the absolute value. So -19 plus -12, well, I'll just add 19 and 12 as if they're a positive. I'm still going to have my absolute value bars after I do this though. 19 plus 12 is 31, but it's negative because they were -19 and -12. So now I need the absolute value of -31, which is 31. So you do that step last. Do the math inside first, take the absolute value last. So what this tells us is that there's 31 spaces between -19 and +12 on the number line, or the distance between them is 31. Now this here is 19 minus -12. So in this case, 19 would be like our p, and then we're subtracting -12. So -12 is like our q. And so this would be the formula you would set up if you wanted to know the distance between +19 and -12 on the number line. And so I'm going to rewrite this as an addition problem like we practiced in the last lesson. So this is 19, absolute value of 19 plus, well, if I change this minus to plus, I have to invert the next number, which makes -12 into +12. So this is just the absolute value of 19 plus 12, which equals the absolute value of 31, which is just 31. As you're doing this, notice, I think you should notice, it's been a while since I did this, but I'm pretty sure that the distance between the ones on the left column should always equal the ones on the right column. And that should lead you to a good answer for number 11 here, if I assigned that. I may or may not have. So I'll do a couple more of these with you, but these are simple enough to where I think most people can do them without my help. So let's see here, I'll skip to number 7. This is the absolute value of 0 minus negative 9. And because I said minus when I looked at this sign right here, that tells me to change that to addition and then invert the next number. And since it's negative 9, I'll change it to positive 9. So this is the absolute value of 0 plus 9, which equals 9. And the absolute value of 9 is just 9. So that tells us that the distance between 0 and negative 9 on the number line is 9. Sure. Here, we're going to find the distance between 0 and positive 9. And I know that looks confusing because you see a minus sign in front of the 9 here, but remember the formula is P minus Q. So whatever number here is Q. The minus sign is like part of the formula. It's kind of clearer to see when you change it to an addition. So instead of minus 9, I'm going to add negative 9. And now it's kind of more clear to see that, actually no, now that I look at it, it's kind of not clear to see the fact that the P in this case is 0 and the Q is positive 9, because now it kind of looks like it should be negative 9. So yeah, I would just rely on identifying P and Q when it's set up as a subtraction. Honestly, it looks more confusing once you set it up this way. Just for this formula, just for the sake of this formula, I think this is clearer overall. Anyways, this is the absolute value of 0 plus negative 9, which is negative 9. And the absolute value of that is 9. So what that's telling us is that the distance between 0 and negative 9 on the number line is the same as the distance between 0 and positive 9, which you already knew, I'm sure, but now we're looking at it with a formula. All right, yeah, hopefully you see the pattern. I think if you're doing these and you get a different number for one on the left and one on the right, that probably means you messed something up. So I would go back and double check and then answer number 11 if I assigned it. And if I didn't assign it, you want to do it. Let's flip ahead. I'm going to mix some problem set 6, some questions from the lesson 6 problem set and some questions from the lesson 7 problem set into this one video. So once again, they have the lesson summary at the top. I like that. Let's start with that. It says, the rules for adding and subtracting integers apply to all rational numbers. So we're just taking what we've already been doing and now we're really focusing on decimal numbers and fractions and mixed numbers. So the sum of two rational numbers, for example, negative 1 and 4 plus 4.3, can be found on the number line by placing the tail of an arrow at negative 1 and then locating the head of the arrow 4.3 units to the right to arrive at the sum 3.3. So we always start at 0 and then go to negative 1, and then from there we would go 4.3 units to the right. So this set of directions right here actually sort of skips what we always do as the first step, which if you're super confident with your number line skill, I suppose you could do that on a regular basis, but not on a test or a quiz. Please do it the way that we've been practicing in class. And then the last part of the lesson summary says, to model the difference of two rational numbers on a number line, for example, negative 5.7 minus 3, first rewrite the difference as a sum, like negative 5.7 plus negative 3, and then do the exact same thing we've been doing with modeling addition on a number line using vectors. That's one of the other great reasons we changed subtraction to addition, is because it allows us to do this vector addition modeling of differences using a skill that we've already learned that has to do with addition. This goes back to mathematicians trying to break a problem down into one they already know how to solve instead of making new rules to do something new. So in this one, they want you to solve each question with an equation and with a line diagram. You can make your line diagrams if you're really neat with them, right in these areas. I would probably use the wider area between the words and then maybe write your equations in the little narrow areas. But for the sake of everybody being able to see my work really well, I'll do them on little separate pieces of paper here. So it says, represent each of the following problems using a number line diagram and an equation. And the first one is, a bird that was perched atop a 15.5-foot tree dives down 6 feet to a branch below. Okay, so these are important things here. He was atop the 15. I don't know if he was a he, could have been a she. The bird was atop the 15.5-foot tree. So it's like the bird is 15.5 feet above the ground. And then the bird goes down 6 feet from there. How far above the ground is the bird's new location? So if we think of the ground as sort of like 0, and because this is a question about vertical height, I think it makes more sense to use a vertical number line, even though I prefer horizontal number lines usually, but let's use a vertical one for this. And I can tell just by looking that, I mean, this bird didn't go underground. It didn't dive so far that it's like below the tree or something like that now, that I could probably just start my number line at 0. And then, I should have a ruler, straight, oh, I do have a ruler right here. All right. So I'll make my number line about like that long. There will be my 0. Maybe I should have made it longer than that. Oh well, we'll make it work. So I know I got to go at least up to 15.5. So I better split this up into about 16 pieces. I can do that by splitting it in halves. Like if this is my 16 here, then about halfway, and I can eyeball this, should be about 8. And so if I split this in half, there's 12. This would be about 4. And then I can split these in half as well. So this would be 14. This would be 10. This would be 6. This would be 2. This might not be detailed enough though, because I got to be able to tell where 15.5 is on here. Well, we can make it work. Maybe you should make yours a little bit bigger than mine. Maybe you shouldn't use the little space in the book. Maybe you should use separate paper like I'm doing. So here's 15, 13, 11, 9, 7, 5, 3, and there's 1. If you're looking at this and you're like, why did he number it all weird like that? Why did he go, like, why did he keep breaking it down in 2s? I only did it that way because I knew the numbers were going to be really tight like they wound up being, because I didn't make the line big enough to start with. And so I knew it would help me be more accurate because I can eyeball where the midpoint between 2 numbers are. And so I was just eyeballing where 8 would be between the 16. I went to 16 because the tree is 15.5. It just helped me wind up with pretty even spaces, which I wound up with. If I had just started with 0 and tried to go 1, 2, 3, 4, 5, the chances of me getting right to 16 at the top are pretty low. I'd have to be really, really good at guessing spaces that way. Okay, so the bird starts at 15.5. That's directly between 15 and 16. The way we've been doing it in class is you start your vector at 0, and then I'll use a ruler. You go to 15.5, and it's okay if you're sort of eyeballing that, and your vector should end there. And then to go down 6 feet, that's down on the number line, or it would be to the left if this was a horizontal number line. And so I got to count 6 spaces back from here. So every 1 space is going to be in between 2 integers. If I start at 15.5, 1 will be 14.5, and 2 is 13.5, 3 would be 12.5, 4 would be 11.5, 5 would be 10.5, and so going down 6 feet, the bird should end up at 9.5. So I'm going to draw a new vector that ends at 9.5, and there's my number line vector diagram for this question here. And so this vector diagram represents the addition expression of 15.5 plus this second vector is going back in the negative direction, or to the left or down. So that's -6. And my last vector ended at 9.5. So there's my equation. There's question number 1. Equation and number line. All right, I'm going to grab a new piece of paper. I'll do maybe like 2 more of these for you. How about I'll skip to number 3. It says, Jake is hiking a trail that leads to the top of the canyon. The trail is 4.2 miles long, and Jake plans to stop for lunch after he completes 1.6 miles. How far from the top of the canyon will Jake be when he stops for lunch? Okay, so they want to know essentially what is the difference. If the top of the canyon is, I guess, at 4.2 miles on the trail. And he's going to stop .6. Then just the difference between those two numbers is how far away he is from the end. So we could do this as a subtraction, but we're learning how to write these as addition. So it's 4.2 plus negative 1.6. And I'll model that on the number line and see what that equals. So I've got tenths here. This decimal place is tenths, decimal place is tenths. So I need to have tenths on my number line, which is going to be a little bit of a pain in the butt, but let's just do it. I'm going to make this nice and long so I have more space than I had for the last one. And I'll make 0 be here, because none of this is going to go into the negative side of the number line, I can tell. And so I'll put, I'll go to 5, since the top is at 4.2. I'll just put 5 here. And so, let's see here. I can use my ruler to help me make sure that this turns out pretty nice. I made this line a little less than 8 inches long. So that means that each inch should be about, each integer on my number line should be about 8/5 of an inch, right? So that's 1 3/5. It's a little bit more than 1 1/2. So I'll just save myself the trouble and I'll mark every 1 1/2 inches will be an integer. So there's my 1 will be there, my 2 will be there. Let's see, where's 4 1/2? My 3 will be there. So now I'll go to about 6. That'll be my 4. And it might not be perfectly even, but it's not bad. So there's 1, 2, 3, 4. And then I need to break these up into tenths so I can do my decimals. And I'm just going to eyeball that. I'm not going to worry about it too much. Let's see here. So there'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the integer itself is the 10th one, so I don't mark that one. All right. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I'm getting a little close on that one. 9. And then the 10th one is the integer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I should have made that last mark. I just went against my own advice. Hold on. Let me time this set up. Let's see here. This is the 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I'm going to cross that last purple one out that I shouldn't have written on there in green. So we're going to pretend this one does not exist. All right. And then we're going to go, I'm going to hold my pen the correct way. 1, 2, 3, 4, 5, 6, 7, 8, 9. The integer is the 10th one. And 1, 2, 3, 4, 5, 6, 7, 8, 9. I had a lot more space on that one. Okay, so we can go with that. And then I'm going to start my first vector at 0, and I'm going to go to 4.2. Let me mark that off so I just kind of know where to stop. I'm going to stop right about there. And I'll start here. There's that. And then I'm going to add negative 1.6. So I need to go back one whole space. So that would be 10 little lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which gets me to 3.2 from 4.2. Remember, don't count the first space you're on when you're going to count on a number line. You always have to move one before you count. And so now I'm going to count 6 more little lines back. 1, 2, 3, skipping that stupid green one. 4, 5, 6. And so I should wind up right here. So I'll start where the last vector ended. I made this a little too close together, but it'll work. Now let's see where we are on the number line. It should be, I think it's going to be 2.6. So this is 2, 1, 2, 3, 4, 5, 6. Yep. So 4.2 plus negative 1.6 is 2.6. So there's your equation and your number line for number 3. All right, and one more. I'll do number 6. It says, if the temperature is negative 3 degrees Fahrenheit at 10 p.m. and the temperature falls 4 degrees overnight, what is the resulting temperature? So the temp starts at negative 3, right? Negative 3 degrees. And then it falls 4 degrees from there. So temp falls 4 degrees. But fall means to like go down or to reduce. So I should be thinking about negatives in that, or at the very least subtracting. So I could solve this by doing negative 3 minus 4, but we're working on adding the inverse instead. So I'm going to think of it as negative 3 plus negative 4. That one I can do really easy without doing the number line. I'll do the number line for you anyway, but I can add these up as positives since they're both negative. I get 3 plus 4 is 7. But then since they're both add-ins were negative, I know my answer is negative. And then this one's a really easy number line. I'm going to do this quick. These are all in the negatives, so I should probably start with my 0 over here on the right, and then that'll be 1, 2. That's terrible spacing. All right, I'll roll with it. Do a better job of spacing than I just did, though. 4, 5, 6, 7. Yeah, I made a big old gap for 1 and 2, and then I realized that that was going to be too much by the time I got to the end of the paper. So this is a 1. Kind of looks like my 2 a little bit. All right, so negative 3. That vector starts at 0. I'm not going to use my ruler anymore. And it goes to negative 3. Pretty simple. And then we want to add a negative 4. So we start a new vector at negative 3 where the last one ended. We count 4 spaces. 1, 2, 3, 4. And that's going to end at negative 7 like we have there. So there's my vector representation of a 4 degree temperature fall with a starting degree or starting temperature of negative 3 degrees. All right. Hopefully you can do the rest without my help.